Hi everyone, this is for help with question 6 in the homework pack. It is quite wordy, so I'm just going to talk you through it. So I've highlighted a couple of things in there to have a look at. You can see a sample of the hydrated nickel there, so it's hydrated and it's a nickel 2 salt. So there's going to be waters in there and the nickel is 2+. So there's 2.5 grams of the hydrated salt. Then there's a reaction here that's going on. Just forget those numbers at the moment. I'll talk about those in a second. I've just wrote on. Step 3, 2.57 of some precipitate of red stuff. Doesn't matter what it is really. And the MR of the red stuff, it says that the red stuff, that nickel DMG2, has an MR of 288.7. And then step 4 tells us that a second sample, 2.5 grams, is heated to remove water crystallization and 1.38 of the anhydrous salt remains. So this bit here is for working out the water crystallization. It tells you here, assume that all the nickel 2+ have been converted into the red precipitate. So there's a bit of information there that I've started for you. So you're going to start off with working out. I've just started at step 4. So you can see there, so step 4 is what I've done. And I'll put a separate video on with the whole, separate photo with the whole of the model answer for this for you. So step 4, nickel salt. We don't know what it is yet. 2.5 grams, 1.38 of the anhydrous stuff, so the difference is 1.12. You can then divide by 18 and get a number of moles, which is 0.06, lots of 2's afterwards. But we can't really tell any more than that because we don't know any more information about the nickel salt yet. So what I've done now is I've gone to step 3 here and used this 2.57 because we've got a mass, we've got an MR, so you can work out a number of moles of the red precipitate. So I've done that here. So I'm just going to move this down. Just use the shaky phone. So you can see that's what this bit here is. So 2.57 divided by the MR gives us 8.90197 times 10 to the minus 3. And that is the moles of the red precipitate. Now it said here, assume that all of the nickel 2+ get converted to that red precipitate stuff. So this moles here that we'd worked out is a ratio compared to 8.90197 times 10 to the minus 3. So that's the moles of that, and that's the water that's given off. If you do the ratio for that, what you find is that the ratio is 1 to 7. So you'll find that there's 7 lots of water for your nickel salt. So we can put that into the formula. So we have used all the information from step 4. We've used the information from step 3. Step 2 is just a reaction to make the red precipitate. So we next need to go to step 1 and we use that 2.50 grams of the hydrated nickel salt. So take our equation. We know that number of moles is mass over MR. Rearrange it to give mass over moles. 2.5 divided by that same number of moles that we came up with there. And it gives us 280.837. So 280.8 is the MR of our hydrated nickel salt. So that is for your nickel 2+ with 7 lots of water. So next you just have to work out what that sulfate, what the negative ion is. So if you do 58.7, which is your nickel, 7 lots of water, it leaves you with 187.4. Sorry, that all adds up to 187.4 that we know. Take your 280.84, which we worked out over here, and it leaves us with 96.1 as the negative salt. 96.1, if you work it out and play around with 2 lots of chlorine or nitrate or any other negative salts you know about, sulfate is your 96.1. So your final formula is nickel sulfate with 7 lots of waters. Hope this helps, guys. Thanks.